in some cases, okay, just by in order to finish some of the integration by parts, we can how to say this, we will be able to get the same integral formula after we apply our integration by parts formula, and then so you can solve for this original integral by subtraction. Okay, it's easier to see if I give you an example, right? So this is the logarithm of x divided by x, right? And so here it's easy to see that our function g prime is going to be 1 over x, and our function f is going to be the logarithm, right? Now, the primitive of g, or one of the primitives, is the logarithm of x. And here the derivative of this is going to be 1 over x, right? Now, so this is f times g, the logarithm of x squared, minus, and then we have, you see, the logarithm of x divided by x divided dx. So this is the same as before, so we can take this summing here, so 2 times this is equal this, and then divide by 1/2, and so now you get this solution plus c, sorry. Okay, you see how this works, right? This is very typical. This appears a lot in trigonometric integrals, right? So for instance, e to the x sine of x dx, right? And let's call this integral s, and then we have the integral, the same integral with the cosine, right? Now let's see, this is going to be where in this case it doesn't matter if we choose one or the other, right? So let's use this as g prime. So we have to find the primitive of this, so this is minus ex cosine of x plus, and then we have ex cosine of x, because then the derivative of e to the x is the same, right? So we have s is this plus, let's call this c, okay, we know this is c, and then here we have the primitive of this cosine is the sine, and then we have minus the integral, or the primitive of this, right? But this is what we call s, right? So we have a system of linear equations, right, with 2 variables. So let's see, we can substitute here, right, the second in the first formula. So we have e to the x cosine of x plus, and then we have e to the x sine of x minus s. We take this sum in here, 2s, and then divide everything by 2. So all of this divided by 2. So this is e to the x divided by 2 sine of x minus the cosine of x. This is the first integral, and then the second one is the same. C is ex sine of x, and then minus s with its minus e to the x halves. So this is e to the x halves plus sine of x plus the cosine of x. This is what you get, and then, okay, plus c and plus c. Okay, don't remember to write your constants. Don't be like me. Okay, it's important, this constant, because depends on many many properties of the original function it's going to be important later on. Okay, so these two, again, these are easy to get if you are you may want maybe to remember them, but really it's super easy to get them in less than 5 minutes. Okay, and so you can use this thing to get in a sense to find recurrence formulas to these integrals. Okay, so what I mean by this is that sometimes you get, for instance, a primitive like this, right? This is the integral of 1 plus x squared to the n, right? Now if n is equal to 1, this is kind of a sequence, if you want, of primitives, right? One value per n, right? If n is equal to 1, then this I1 is the arctangent, right? Plus c, okay? Well, but we can remove the constant here. We don't really want to care too much about the constant. Well, we can talk. It's okay. Okay. Now the question is, how do we find the recurrence formula for this? Because so think about it. If this is n equals 2, then this is already hard to compute, right? If n is equal to 3, it's harder. So, right. So if there's a way that we can compute in as a function of in minus 1, then because we know I1, we can compute I2. With I2, we can compute I3, and so on. Okay. So how do we see this? Well, we can apply integration by parts to this, right? So this is the integral of 1, or the primitive of 1 plus x squared divided, to the n plus 1. And then we have to find the primitive of this using integration by parts, right? And so, well, before doing that, okay, what's easy to see is that we can write the numerator as this 1 plus x squared minus x squared, right? This is 1, we're just summing and subtracting 1 plus x squared, right? And this is the x. So we can now separate this part, and this is 1 plus x squared divided by 1. This is just 1 over 1 plus x squared to the n dx, but this is just our integral with index n, and then we have minus x squared divided by 1 plus x squared to the n plus 1 dx, right? And now we can integrate this thing by parts. Okay, and now we have what? We're gonna find, wait a minute, in order to, let's say, how to say this, we want to be able to find some, so we want to be able to integrate this, right? So this is going to be 1 plus x squared to the minus n minus 1, right? This is what it is. So in order to integrate this and get 1 plus x squared to the minus n divided by whatever, right, we need to get in the numerator something that's the derivative of this, and this is equal to 2x, right? Now here we have an x squared, so this is equal to x divided by 2, right? You see, x squared 2 divided by 2, right? And now we have that the function, this is x times the integral of this. So let's say first, so this is 1/2 of, and then we have x times the integral of this. So this is 1 plus 1 over 1 plus x squared to the n, and then divided by minus n, so minus n here, right? You can do it on your own if you want, and then plus 1 over n times the integral of this 1 over 1 plus x squared to the n, and the derivative of x, which is 1, right? dx. But then again, this is in, right? So this is 1/2 of in divided by n, right? Minus, and then we have x divided by n 1 plus x squared to the n. Right, now we can make this, find this together. So we have that in plus 1x is in, right? And then, sorry, this is in of x, and then minus 1/2 of in over n, so minus 1 over 2n in x. So let me rewrite this. This is 1 minus 1 over 2n times in x, and then plus minus plus x divided by 2n 1 plus x squared to the n, right? You can get this formula. Okay, so now let me erase this part. Now having that, we can now find all the values that we want of this integral by just substituting here. So we have n equals 2, then this is I2 is just 1 minus 1 over 2, so 1/2 of this, which is the arctangent. Well, this is obviously plus c. Well, not, you don't really, yeah, the plus c is here already, sorry. So plus, and then we have x divided by 2 times 1 plus x squared, okay, and then plus c, right? Now if n equals 3, this is I3, which is 1 minus 1 over, in this case, well, sorry, this is n equals 2, right, for this formula to occur. So this is n equals 2 minus 1 minus 1/4, 3/4 of this, right? So let's call this I2. Let's not substitute. And then we have plus x divided by 4 times 1 plus x squared plus c, right? And then you can input here this thing here, okay? So you see how this works. We now have a formula for this integral or this primitive as a function of n without having to compute more primitives, okay? And that's kind of the power of the integration by parts.